so this first topic that I'm going to talk about, it's understanding the product rule of exponents. And so what happens with the product rule is if we have something that has the same base, so it doesn't matter what the base is, it could be x, it could be a, it could be anything, any number. So if I have x to the a times x to the b, what the rule tells me is since they're being multiplied like this tells me that I add the exponents. So this would be xa plus b. Does that make sense?
Yes.
Okay, so in this first example that we have here, we have n to the fourth times n to the third. So the first thing we want to ask ourselves is, are those the same base? And clearly we see they both have n as their base. And so that tells us then by the rule, I should be able to go 4 plus 3 in the exponent. And so my answer is n to the 7th. Okay? Now, by the... oh, that's funny. This one is down here. I'll flip them, and the work for this one's going to be up here. Now, what they're trying to say in that first example is to write it without exponents. So n to the fourth means what?
Sorry, Professor, it cut off. What did you say? Can you repeat that?
Oh, yeah. So n to the fourth means what?
4 n's?
Yeah, well, 4 n's multiplied, right? So it's going to be n times n times n times n. This piece here is n to the fourth, right? But then it's multiplying that with n times n times n. That's my n to the third. And so you see how many n's are being multiplied?
7.
It's 7. And so this is how they would write it without exponents, and this is how you would write it with exponents. That's all it's saying. Let me give you guys one to try. I want to see if you understand this. So if I gave you x to the 5th times x to the 7th, what would that be? And I mean to write it as an x with the exponent, not multiply it out. So what would that be?
X to the 12th?
So it's x to the 12th, right? Because it'd be 5 plus 7, and that is 12. That's all this is. That's the exponent rule. It's just, can you add them up? It's not too bad at all, right? Okay, let's go on to the next one. So this one was for products. So in products, we add the exponents. In quotients, the rule tells us if I have x to the a over x to the b, I'm going to go x to the a minus b. Now, the rule, it's kind of funny. They only show it one way. I typically don't like that. So like in this example here, right, we could write it without exponents. So you could go x times x times x times x times x times x times x. That's 7 of them, right? Yeah. Over x times x times x times x. And then what we could do is that cancels, that cancels, that cancels, that cancels. So that leaves me x to the third as an answer, right? That's showing it the long way. What you could do is go x to the 7th over x to the 4th. Could be written as x to the 7 minus 4, which will give me x to the third, correct?
Yes.
Now, one thing that I don't like about the rule is it's so specific. The answer ends up being the same. If I had flipped it this way, correct? If I had flipped it this way, what would happen is you would think, okay, by the rule, I have to go x to the 4 minus 7, right? Which would then give me x to the negative 3. And then you needed to know there's another rule that says x to the negative 1 is 1 over x, right? So that makes everything go down. So I would have gotten x 1 over x to the third. But that to me is, it's too much work. So the way that I look at this problem is I look at it this way. What number is bigger, 7 or 4? 7. So I'm going to, instead of doing all that work and using those two rules, I'm going to go like this. Well, x to the 7th was bigger, so then I'm going to subtract the 4 from it. So then that's going to give me 1 over x to the 3rd. So depending on which exponent is bigger, you can take the other one down to it and subtract it. Okay?
Yeah, the other way was lost.
Yeah. Because what ends up happening is you subtract like this, right? Top minus bottom. But then you end up with x to the negative 3. And I'll show you. There's actually a step I skipped just so you could see. It would have been x to the negative 1 to the 3, but you don't know that piece yet. So then that would do, that would use this rule inside the parentheses, which would have given you 1 over x to the 3rd. And then that would be 1 to the 3rd, which is that, and then x to the 3rd, right? That's the step that I skipped, but it's just a bunch of stuff. These are two rules you should know. So I strongly recommend that you write them down, but it's important that you understand. I just look at which is the bigger one and then move that way. Does that make sense?
Yes.
Okay. This one's going to take some practice, I'm sure. Let me do one more for you. So if I had done, let's say I had done x to the negative 5 over x to the 4th. Which is bigger, the 4 or the negative 5?
4.
The 4 is. So then that tells me I'm going to go 1, and then I'm going to go oh, no problem, Jay. I'm going to go x to the 4th minus a negative 5. So it's important. The sign doesn't change of the number. It's always going to be minus whatever the number above is. Does that make sense? So what should I get? X to the what?
9.
To the 9. So that's the answer to this one. This would be the easy way to do this one. But that's how it works. Does that make sense to everybody? The quotient rule for exponents? And if you ever get confused, you can always go back old school. That will always work. Okay, till you get comfortable with the rule. Because you can see by looking up here, right, we had 7 on top, 4 on the bottom. We ended up subtracting 4 from our number, right? And then by the same token, this one that I did here with the x to the 4th over x to the 7th, it was x times x times x over x times x times x times x times x times x times x. And what did we see? 4 of them again disappeared or got canceled, and so we only had x to the 3rd in the denominator. Okay? All right, off to the next one. All right, so in this case here, this is just really labeling. It's nothing more. So in this problem, it's saying what is the leading coefficient? So the leading coefficient here is going to be the number in front of the variable with the highest exponent. So in this case here, what is the highest exponent?
18.
18 is a constant. So
the 8th?
That's correct. So it's to the 8th. Good, Itzel. So it's to the 8th. And since it's to the 8th, what's the number in front of v to the 8th?
1.
Close.
Negative 1?
That's it. Itzel. Very good. So my leading coefficient here, is -1, right? Because I'll rewrite it so you guys see it in descending order. It's -1 v to the 8th minus 3v plus 18. Got it? Now, the degree of the polynomial, which is another important thing, and I should write that down in a different color. Degree of the polynomial is what is the highest power. That's it. So the degree of the polynomial is 8. Okay? Here, let me give you an example just to see if you guys totally get it. So if I get v to the 3rd plus 4v to the 5th minus 7v to the 10th, what is my leading coefficient?
4v 5.
-7.
It's -7. And notice, it doesn't have a variable to it, it's just a number. And the reason it's that is because which is the highest v power? It's this one, right? What's the number in front of it? It's that 7, but usually everything is written with plus, so that means this has to be a -7. Does that make sense?
Yes.
All right, so the degree, I'll just do it this way. The degree of the polynomial is what then? It should be 10, right? Because it's going to be the highest power of that polynomial. Okay, here, let me do another one. All right, leading coefficient.
-6.
Does everyone agree with that?
Yeah.
The degree of the polynomial?
3.
That's it, it's 3. Okay, one more just to make sure. So you can see this topic should be one that you guys just go through pretty quickly. So if I gave you, oopsie daisy. If I gave you 6v to the 3rd plus 7v squared plus 4v minus 17, what's the leading coefficient? It should be 6. The degree of the polynomial?
3.
Should be 3. So just to have the right color, that's how I got that. This is how I got that. Okay, just to demonstrate it. Because it's the highest exponent, right? How do you guys feel with this?
I'm good.
Okay. Let me do one more then. Now in this case here, it's talking about adding or subtracting polynomials. And so when adding or subtracting polynomials, in order to be able to add like terms, so in this case, everything is about like terms, right? And like terms means that we have the same variable to the same power. Okay? So, one thing that I used to do when I was a kid is, so I wouldn't get these wrong, I'd look at all of them that were the same variable to the same power, and I'd highlight them because I had way too much time on my hands, I guess. Negative 6v doesn't have anything else, and then I'd have my constants like this. That way it was obvious to me. So the dark green would be that 5v squared plus 3v squared, right? Then I'd have the red 6v, and then it'd be plus 7 minus 2. Does that make sense?
Yes.
Okay, so the only thing that I can add are things that are the same. So 5v squared plus 3v squared is 8v squared. There's nothing to add with the 6v. And then 7 minus 2 would give me plus 5. And this is my answer. We okay with that? All right, so let me give you something like this. 2x squared plus 4x minus 7 minus 3x squared plus 5x minus 4. Now, one thing that's important here, in the other one, because it was adding, I didn't have to worry about signs changing. But with that negative in front right here, this negative, what it forces me to do is distribute the negative and change the signs of everything in the parentheses that follows it. So I'm going to get 2x squared plus 4x minus 7 minus 3x squared minus 5x plus 4. Does everyone agree with that?
Yeah.
All right, very cool. So now we're going to try to get things that are the same. So I can see, I don't want to bore you guys with highlighting, but it's something I used to do. I'm going to get 2x squared minus 3x squared plus 4x minus 5x minus 7 plus 4. Okay, so this first group here can be added. So what can I get with, what am I going to get from that?
-1.
So I should get a negative 1 x squared. And then from this group,
-1.
no one wants to talk. I love you guys. That's cool. And what about this
Can you
group?
just put it up a little higher because we can't see the bottom? Yeah, you go.
Oh,
Thank you.
sure. And what about that piece?
-3.
Should be a negative 3. And so this is my solution to this one. So the thing to be careful about here is this negative in front of this parentheses distributes because that negative is multiplying with everything in that parentheses. Does that make sense?
Yep.
All right, let me give you guys one to try, and I can tell you guys are all really excited about mathematics. All right. Try that one, and then I'll do it. Okay. All right, let me see. So oops. And then I should get a negative 9. Right? And this, I can put the 1 there if you'd like. This piece here, I just thinking about money is a cool way to look at this. So the -7 means you owe someone $7, and then a -2 means you borrowed 2 more. So if you owe $7 to someone and then you borrow 2 more, you're going to end up owing them more, not less. So you end up owing them $9. Does that make sense?
Yeah.
All right. Do you want me to give you guys one more just to be on the safe
Yeah.
side? All right, one more. Ah. Oh, we lost people. That's funny. Okay, you want me to do it?
Yes, please.
So I'm just writing it so it's in descending order. And then I'm going to change signs. Does that make sense? Oh, probably higher. Are we good with that?
Yes.
All right. Okay, so that's all I got in terms of topics to talk with you about today. I'll stop recording and then I'll answer any questions you might have on topics that you need help with. Okay?